Okay, before I start with today, we're going to actually look at the graphs of sine, cosine, and tangent. And you don't need to write this part down, but I just want to talk to you about something. If I told you y equals 2x plus 1, for example, okay, when you graph this, you can actually graph it by the method we know, start at 1 and use over 2. But you can also graph it by making points on the line, right? So for example, I could plug in a 1 for x, which would give me 2 times 1 is 2 plus 1 is what? What would it give me? An input of 1 gives me output of 3. And then let's try putting in another point. We're going to put a 2 in. What's it going to give me? 5. Okay. So I can either, do I need to keep going? Do I need thousands of points? No. How many points do I need to build a linear line? Just 2. And I can just connect it and move on. Okay, well, guys, that's the graph of y equals 2x plus 1. We are going to graph, okay, the graph of y equals sine of x and y equals cosine of x and tangent of x. And they are not straight lines, okay? Sine and cosine we see the most, and they look a lot like radio waves, okay? If you've ever seen in science pictures of radio waves, that's what they look like, all right? You know, you can change the amplitude so the radio waves is really skinny or really wide, right? The wider they are, the farther they go, okay? That's what we're doing. We're graphing that. So on your piece of paper, we're going to do the graphs of sine, cosine, and tangent. Right? And we're going to talk about what we call the hot spots first.
So we eventually have to graph secant, cosecant.
Tomorrow. Yep. Now, guys, the reason we're creating hotspots is because if you look at the unit circle, we have the unit circle divided into lots of different stops. Okay, look. Think about the x values. March yourself around the unit circle with the x values because we're talking about sine or cosine. If we're talking about sine, we're using x or y. Which one? Y. Okay, if we're talking about cosine, we're using x. So if you look at the x values, 1, root 3 over 2, root 2 over 2, 1/2, 0, and so forth, right? Negative 1, negative root 3 over 2, negative 1/2, 0. Which ones will we consider hot? Which ones will be easy to graph? The zeros and the 1s or the root 3s and the root 2s? Right. So what we're going to do is we're just going to take a few off of that unit circle and graph the easy ones, okay, to get a general idea of the graph. Just like in the straight line we talked about, we don't need lots of points, right? Same here. We just need enough to know what the graph is doing. So in order to do that, the hot spots that we're going to use, we're going to start around the unit circle, and we are going to just hit the quadrangules, right? Which are the major points. If you think about it, it would be the farthest to the right, the highest, right? Correct? The most to the left, the lowest, and the farthest again to the right. Do you see? Because if I stopped here, okay, my unit circle goes all the way to here, okay? The x coordinate. So then, the hot spots that we're going to do, if you have a number line, draw yourself a line and put 9 spots in it. And preferably your lines are spaced pretty evenly. Just quickly, just jot 9 little dashes, kind of evenly. Right in the middle is 0. So one in the middle, then line over. And then you're going to go around your unit circle like we talked about. So here's your unit circle. You're going to go around it on only the major hot spots. Okay, and we're going to count by radians. Our input is going to be radians. So your major hot spots would be 0. What's your next hot spot? Pi over 2, right? The easy ones. Okay, the ones that are the easiest to remember. So 0, pi over 2, what will be the next one? Pi. Then down at the bottom, the lowest point is 3 pi over 2, and then back home, right? 2 pi. So I started at the beginning, went to the tallest point, the farthest, the lowest, and back home. Right? Now go the other direction, the same exact points. Negative pi, which you just count the other way, right? Negative pi, and so forth. Those are your hotspots. We're going to use those over and over. Now we have two vocabulary words. One of them is called the period. In other words, it's meaning how much of the graph do I need to see its entire picture. We know it's a wave, right? So you need to know how far out do I need to. Do I need to make an entire unit circle in order to see it, or is just half a unit circle enough? Okay, so let's look. The definition is the degrees, the number of degree, or radians, taken to complete one cycle. In other words, where you look is you look at the x-axis. Okay, your next vocabulary word is amplitude. It's a distance from the graph's x-axis. That's important. From the graph's x-axis, the distance from the graph's x-axis to the higher low point. And it's always positive. It's always positive. Okay, now then, for the next part, you're going to need a little bit of room. So I'm going to actually start on another page. And I'm going to draw myself at the top a unit circle. And we're going to make 3 columns. A column for sine, a column for cosine, and a column for tangent. Okay? The first thing we're going to graph is we're going to talk about the hotspots. In other words, which stops do we decide to make when we want to graph this on a line? Okay, it's a circle right now, correct? So we're taking a circle and we're going to graph it in terms of x and y, right? Because if you think about this for a minute, this is on the coordinate grid, correct? What point is way out here? The most farthest we travel on the x-axis is what point? 1, 0, right? We just stop at 0. The graph keeps going though, doesn't it? The farthest out that we went in the circle is 1. Hence being unit circle, we're using a radius of 1, okay? Now, we could plot this point here on the graph, right? But we're going to plot only easy ones. So go to this one. What is this point called? 0, 1. Okay, here. And then to this one would be negative 1, 0, agree? And this would be 0, negative 1. Those are the important spots. Okay, but it's not like what you think. I can't graph x is 1, y is 0. That's that right there. That's that point there. What I'm asking you to graph is y equals sine and y equals cosine. Though these are part of the answers, okay? So what I'm going to say to you is this. Now let's label for a second. You might do it inside so you have room for this. Let's label the radians all the way around. So this would be 0 radians. What radians up here? Do you remember? Pi over, good, yay. Pi over 2. What's here? Pi, 3 pi over 2. You guys remember them, right? All the way back to 2 pi. Okay, circle. The first thing we're going to graph is called y equals sine of x. And I'll use orange to start. So this is this graph. And what's different is the x stands for the radians. So we started our beginning of our unit circle here, 0 radians. So I'm going to ask you to graph for me y equals sine of 0. Okay, go to 0. Here's 0. Do you agree on there? I want y, whatever y is, its sine is 0. So we input 0, and I want to see what we get out. Well, what is the sine at this stop right here? How do I know which is which? Which one of these is sine, the 1 or the 0? Do y'all remember? No? What's the rule? This is the cosine and this is the sine. Y'all remember? Because the hypotenuse is what? 1. Are y'all remembering now? X is cosine and y is sine? Okay. So that's the x and that's the y. So x is cosine and y is sine. So if I'm here, I want the sine value. The sine value then is what? So here, march around the unit circle with me then. If I'm at pi over 2, if I plug in pi over 2, what sine value am I going to get out? 1. If I plug in pi, what sine value am I going to get out? 0. What is sine then at 3 pi over 2? Anyone? What is sine back at 2 pi? 0. Are you understanding what I'm saying? So let's fill in the table real quick. Sine at 0 gave us 0. Now then, let's find sine at pi over 2. So I'm asking you, what is sine at pi over 2? What are we doing? We're trying to get points to plot, aren't we? I'm not going to plot these points. These points aren't going to work. Okay? They're going to work on a number line to tell us what to do. Okay? So then let's do sine. Sine at pi over 2 is 1. So I input pi over 2, and what did I get out? That's kind of a weird order of pair, isn't it? Pi over 2, 1. But that's what happened, isn't it? At pi over 2, in other words, if you put pi over 2 in this equation, sine at pi over 2 is 1. Are you all seeing where they're coming from? Go to the next one. Y equals sine of pi. Okay, well my input, here's my original equation. Your input is your x. So my x is pi. And what's my output? What is sine at pi? There goes 0. What's after pi?
3 pi.
Sine at 3 pi over 2. So in other words, look at the equation. What's your x value? Your x value is the radians. I put in 3 pi over 2, and what do I get out? Negative 1. Last one, back home. Y equals sine at 2 pi. Kind of ended where we started, right? You plug 2 pi in, and you end back at 0. Okay, watch for a second. Look. I'm going to use blue for just a minute to show you what I did. We're graphing ourselves around the unit circle, right? Using sine. So we're going to say 0, 1, 0, negative 1, back to 0. Do you see it? You're working your way around with the y values because it's sine. Y values are sine. Okay. All right, then let's move on. Let's use our data, these points right here, and graph them on that piece of paper I just gave you. So get your half sheet out. Everybody got it? And the first graph is sine. How many marks, how many hot spots did we just loop around? But we're going to go both directions, so go ahead and put me 9 dashes on your paper for me, please. 9 dashes. And just space them evenly. So start here. 9 dashes. Kind of space as evenly as possible. and then put in your 0 right in the middle. And which ways did we go? Remember, we stopped every single quadrangle. So just label the quadrangles all the way out. What were they? Pi over 2? Oh, that's it. Yeah, label them all the way. In other words, if you're going to march yourself away around the top, the most left, the bottom, and so forth. Okay, now take your points that you worked so hard, put it on there and see what happens. What's the highest that we go in the unit circle? What's the lowest we go? So then you've got your x's, you've got your input. We input 0, input pi, you got that. Now let's build your axis. So here is my y-axis. The highest I went is 1, and the lowest I went is -1. You want to try to get them even. Yeah, it's a huge pattern. Excellent. Okay, and then graph the points you just made. Here we go. Ready? 0, 0. I'm going to graph it in orange because I went around my unit circle in orange. So sign for me is orange today. Now pi over 2, when we were at pi over 2, way up here on my unit circle, where did we stop at? At 1. So pi over 2 is way up high. Remember, that's the high spot on my graph. Okay? At pi, where are we? Back at 0. 3 pi over 2 down to -1, and back to 2 pi. Look what happens when you connect these points. I don't need every single point to work. That's enough to give me a general idea. And if you, bless you, if you plotted all of them, they would fall all on that line. Now go the other way.
Does it have to be like an arc or?
Yeah, good question. It is a rolling curve. It's not a V. That's a very good question. Now go the other way. Okay, we went 0, 1, so we're going to go to -1, back to 0, back up, and back to 0. And the same, it'll just be looped down. I always have trouble making my other side look as pretty, but it would be better if you started to live from the left, probably.
So, I'm going to ask the question. Why is pi such a crucial number?
Okay, guys, you have just built sine. That's it. Yay. Okay, now then let's answer these questions down here. They're actually very easy. What's the domain? Okay, what's the domain? So think about it. The domain is the input, right? How many times can I loop around the unit circle? Because that's what we did. The input was all the radians. That's right. So the domain could keep going. The period is how much of the circle did it take for me to see the whole graph. So it started at 0 and up, all the way down and back up, right? So it took a whole loop, didn't it? So we're talking about the period was from 0 all the way to 2 pi. It took the entire loop of the unit circle to see. Range, okay, how high and how low did I go? From -1 to 1. Remember always to put the negative first. Okay, the amplitude tricks kids. The amplitude is not 2. Amplitude measures from the x how high we went, and from the x how low we went. So how high and how low, not together, just from the x how high and from the x how low. 1. Right, it's 1. Not 2, it's tricky. From the x how high, from the x how low. So the amplitude is 1. Okay, you're finished with sine. Now we're going to do the same thing, and we're going to go through and pick out cosine. Okay, so y equals, so draw yourself a little, we're going to do 3 today. So y equals cosine of x. And for cosine today, I'm going to use Greek. Okay, look at me really quick. Watch this. Watch my hand. I'm asking cosine of x, which can be confusing because x, remember, are radians. We're inputting radians. In other words, what's cosine at 0? What's cosine at pi over 2? What's cosine at pi? What's cosine at 3 pi? Do you understand what I'm saying? The input is radians. So then we have an ordered pair x, y. And you're going to say, all right, guys, what is cosine at 0? In other words, our x is 0. Remember, x is a radian. That's fine. What is cosine of 0? We're going to use orange here. Here's 0. Which one's the cosine? The x value or the y value? The y. This is cosine and sine. So 1. We're going to make it stop at every one. So what is cosine at pi over 2? What is cosine at pi? 3 pi over 2. We're stopping at all the quadrantials, right? Right? We're making a stop at each important spot because there's no reason to stop at every single spot on the unit circle. We can get an idea with just the main ones. Does that make sense? Okay. All right, now then come over here and list your points. Okay, before you do that, let me ask you a question. I'll use green. Let's think about this for a second. Let's march our way through the unit circle with just cosines for a second. Cosine here is 1. What's it going to be next? 0, -1, back to 0, and back to 1. Do y'all see them? They are the x value. Cosine is x, y is sine. How come? Cosine is adjacent over hypotenuse, correct? And adjacent is always the x value. And in the unit circle, what's the hypotenuse always? 1. So x divided by 1 is just x. Okay?
So not the x's that are changing.
Say that again.
X's are going to be 0, 1, 2.
Right. Because we're still stopping the same spots, aren't we? What are we looking at though instead? Instead of looking at the cosines and sines, we're looking at the sine.
Okay.
Does that make more sense? I did. I said it backwards. Yeah. Okay, he's saying, are my stops all the same? My input is always the same. So at pi over 2, though, I want the output, which was, where am I at now? 1, 0. At pi, my cosine value is, I'll use green here so you can see them. What's cosine at pi? -1. What's cosine at 3 pi over 2? You're way down low at 3 pi over 2, right? But it's 0 because you're looking for the x. Cosine at 2 pi? Okay, let's see what the graph looks like. No, the input, right, is x. Input's the x, so we start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's the input.
Yeah, okay, gotcha.
Because you're thinking, I'm looking at the x value. I'm telling you y equals cosine of that.
Oh, okay.
It's very confusing. Okay, take your graphs. Find them. What are we going to graph this time? Cosine? Did you find it? How many marks are we going to put? It's better to go ahead and put them all even. Just count out. Make your mark with 9 spots. Put 0 in the middle. Okay, what are our stops? All the quadrantials. Pi over 2, pi, 3 pi over 2, and 2 pi. You'll be so good at those. How high and how low does my graph go? 1 and -1. And then I'm going to look at my points. You could, once your points are gone, watch for a second. Once your points are gone, look, I have mine covered. Even if you just cover them, just march yourself around cosines. 1, 0, -1, 0, 1. March yourself around the unit circle with cosine values. That's the fast way. 1, 0, -1, 0, 1. If you're going to graph sine, march yourself around the sine. 0, 1, 0, -1, 0. Plot your points. Cosine starts at 0, 1. I'm going to use green. Then I move to pi over 2, 0. -1 at pi. 0. And back to 1. Make sure they're rounded. If you continue the pattern, you are at 1, so 0, 1. You have to keep going the same exact direction. If you don't, you'll mess it up. Okay, now try to guess the domain and period. You guys try to fill that in. That's the domain. What do you think? How far can we go? How many times can we wrap around the unit circle? Because that's my input, right? The radians. Okay, all around. Look at your picture even. Just keep going. How much of the graph? How many rotations do we have to make to see the whole graph? So 2 pi. What's my range? -1 to 1. Okay, be careful about the amplitudes. From the x, how high? From the x, how low? So what's the amplitude? 1. Okay, everybody have it filled in? Yeah, for these pictures it will. I'll show you. Okay, now let's go to what's next? Oh, tangent. So do the same thing. Oh, hang on though. When you're going to fill in the points, I need to do this a little different. We'll see why in just a second. Okay, when you fill them in, you need space in between each one. So we're going to say y equals tangent of 0. Leave you a space. We're going to have to put more in here. Quadrantal's not going to be enough. I'll show you why in just a second. Use some space. In between. We're going to have to go back. Those 4 aren't going to be enough. Like I wrote tangent, leave some space. Like I'm going to write in the middle here. To fill in right in the middle. We're going to have to make more stops. Just the quadrantal stops aren't going to be enough for us to find the nature of the graph. I'll show you how come. What color, guys? Blue. Will blue show up? Let's show you. I think blue will show up. Okay. Here you go. Let's go to tangent. Tangents aren't listed. How do you find tangent? You ask him nicely. He might show up. Tangent is what 2 things? Y over x. We have all the x's and y's. We just have to do what to them? Divide them. So on here, we're going to write tangent. Tangent is the y, 0 divided by 1. What is 0 divided by 1, guys?
0.
So tangent is 0. Let's finish. Go to this one. Here, tangent would be y divided by x. 1 divided by 0. What's 1 divided by 0? Undefined. That's right. So we're undefined at pi over 2, guys. Tangent's undefined at pi over 2. Okay? How about over at pi? Tangent would be y divided by x, so 0 divided by negative 1. What's that going to be? What's tangent over here? 0 again. And the last one would be tangent negative 1 divided by 0. What does it weigh down at 3 pi over 2? Undefined. So where is tangent undefined in my unit circle? At pi over 2 and at 3 pi over 2. What is it at 0 and at pi? What's tangent over there? 0. So if you're going to march yourself away around the unit circle, 0, undefined, 0, undefined, and 0, it's not going to give me a very pretty graph, is it? That gave me nothing. So, right, so let's get let's get my graph out. Did you do that? Tangent? No, we're going to let you off that. Okay, and label them. Pi over 2 pi, 3 pi over 2, and 2 pi, and so forth. Okay, so look at your points. Let's graph what we know. What did we figure out? Here, I'm just going to put these next to each other. Maybe they'll fit. Ha, there you go. Okay, so when I plugged in 0, x and 1, your x is your radian. 0 radians gave me what tangent? 0. Okay, pi over 2 radians gave me what tangent? Undefined. Pi radians gave me back to 0. 3 pi over 2 gave me back to undefined. And 2 pi is 0 again. So we went from 0, undefined, 0, undefined, 0. Okay, we're yellow, so let's plot yellow. 0 radians is 0 tangent. So 0, 0. If pi over 2 are undefined, guys, that's an asymptote. You can't touch it, right? Divided by 0. So that gets a dashed line. You're not allowed to be there at all. Because being at that spot means you're dividing by 0. Are you allowed to divide by 0? No. So you can't be there. Does that make sense? Okay, go to pi. You're back to 0. Well, look, way down here, 3 pi over 2, that means negative 1 over 0. Are you allowed to divide by 0? Nope. So you can't be there either. Back to 3 pi over 2 is no thank you. And then 2 pi. And go the other way. Oh, wait a second. You have to be careful on this one. When you go the other direction, finish it up. And then here. Okay, then tomorrow we're going to finish with the tangent graph. Okay? All right, so we're done for today.